Thank you. So, yes, I'm going to present Slipshow, which is a full-featured presentation tool. And of course, I'm going to use Slipshow to showcase Slipshow. So, what do I mean by full-featured? We are just going to be on the same page on this, so I'm just going to list some of the features so we can see how much full-featured it is. And so, I need to go a bit faster. Okay. So, I don't know if this looks many features, but actually it's just that I run out of space, so I'm going to add the remaining one. Okay. So when I say full-featured, I mean this. And I wanted to speak a little bit about all of them, but that's a lot, and I only have not that many minutes. And so I'm going to set a timer and speak about all of them, but in 10 minutes maximum, just to give a bit of pressure. So what is Slipshow? It is a compiler that compiles Markdown files into something that then can be viewed. As you can see here, it's a regular Markdown, so you have titles, things like that. But you also have some specific annotations, which I will call actions. So here we have two actions. We have the pause action and the emphasize action. And when we are going to execute the, like to render it, the action will be executed one by one. So for instance, the pause action has hidden what comes after. And when I press right arrow, it displays what comes after. The next action, emph, is attached to something. So it is attached to surprise. So when it acts, when it is activated, that is next time I hit the right arrow, it will act on the thing that it's attached to emphasize it. And that's all there is in Slipshow. So linear document and a linear set of actions, and each action will be executed one by one. So I hope I will be faster for the next ones. So one good thing about this compiler is that it generates a standalone HTML file. So I was a bit like inspired by Beamer that I was using before, which is LaTeX mode for presentation, where you generate a PDF, and then you can send the PDF to someone, and there is no need for internet, no need for anything. You have this HTML file, you double-click on it, and everything is included. It is not based on slides, so here we are on step 53. The idea is that we are not using discrete presentation where every time we remove everything and just show the next one. We are relying on a more continuous paradigm for displaying what we want to like for our story, the thing we want to say. Here is another example of an action, and it's focus. And so you can just, if you want, do this and have a focus on a specific part and maybe have more things on it. But you have this action, and I can also say that actions can take arguments. Just like here, I say what I want to zoom. It is not based on slides, but we now have support for slides. So here I did not zoom on them, but I could zoom on them and it will look just like regular slides. You can annotate your presentation. So, for instance, I can do this. Hello. You can remove your annotations. One important other thing is that you can execute custom scripts. So you are not forced into a specific set of actions, but you can just write a slip script and have the action exec to execute it. So here we have a slip script, which is just JavaScript, which queries all the list items, and for each of them set the class red to true. And so at some point I have some CSS which says that the red class should be red, and when I just goes next, this is executed. And it is bidirectional. That is, it's an important feature. You can go back. And here, it's important to see that it's not so easy to go back in every case. For instance, I have allowed the execution of a custom script, but fortunately, not with the SML solver. I can still go back and invert the custom script. Okay, look. I have to go faster. So it has support for videos, and you cannot hear, but it has support for videos. Ouais, it's a Stack Overflow. It has also support for embedding PDFs. So if you have some other presentation written using PDF, so here is the 50 first pages of the OCaml manual. It has a table of content. It's not very pretty, but I included it as a feature. It has Markdown output. So if you want to use Pandoc, then Pandoc has support for the annotations. It is sufficiently standard. But if you want to generate using OCaml your website, your blog post from a presentation, it's possible. You can write your presentation with hot reloading. So here is a video of it. On the right, you have the browser, which is connected to localhost, and on the left, you're writing. And when I save, it is updating on the right without jittering, which is quite difficult to do. What else? It is available as a static binary, so you don't need to have OPAM. You can just download the static binary. It is available as a VS Code extension. So here I'm calling the preview, Slipshow preview command palette thing. And it's working. So also it's nice to distribute it to user like Windows user who need a GUI. If I add a theorem, it's a theorem. It is available with a GUI made with Story. It's the same. You have a live collaborative editing. So if anyone wants to click on this link, sliphub.shum.net, it will go to this website, and we can collaboratively edit things, and you can see that it's working. I guess I don't really have the time to do this. I only have 3 minutes. I'm going faster. Extensible via JavaScript. Oh, there is a speaker view. I have it. No, not here. I have it here. So I have a speaker view where I have the time and a mirrored presentation. And also I can add notes so that I don't forget to show the speaker view like the notes. And I should not forget to show you that I can add the... Yeah, it's going to be a bit long if I want to show everything. Okay, not this one. Yes. You can split your things into multiple files without arrows. You have support for front matter, adaptive scaling, so it will look the same no matter the size, and update. So you don't need to, it will be exactly the same pixel per pixel, modulo the fact that you have less pixels. You can add mathematics. All of this is embedded in the PDF. It is open source. You can define the dimension. Here it is 16 by 9, the ratio. It has a help page, documentation and tutorial. This I'm going to go fast because you can have a visual structure for your presentation. Syntax highlighting, mobile support, I don't have time to show it. Support for theorem and blocks and multiple environment. It's sponsored by NLNet, thank you. I got a grant to work on this. It is lightning fast for some meaning of it. The name is a pun on slideshow, so for French people, it is like slideshow, but instead of sliding, you're sleeping. Offline first, you don't need internet when you have it. You have predefined actions, a lot of them, and you can define your own. It has a nice logo. I'm not that bad on time. It is type-safe. At least it's implemented in a type-safe language, but not type-safe in itself. I don't have a pointer device. I was hoping to have one. It is versioning friendly because the source code, the source of the presentation is not like in a big GUI, but it's just a text. It has a friendly community. It is secure by design, and you cannot get help because I have tried a few times, and the LLMs don't crawl NOS and don't know about it. And of course, it can make coffee. And I stopped with 25 seconds of margin. That's great. I will have more time for the rest. So that's all the features. Some of them are a bit just to populate the slide, but now what I'm saying is having multiple slides is always difficult because they have links with each other. This one is a very brand new feature where you can record what you are writing. So for instance, you write your presentation with hot reloading and you want a speaker view. So when there is a reload, what should happen with the speaker view if it's open? You have standalone HTML file, but you have support for video, so you need to have this. You have, what else did I want? So you, like the bidirectionality means that for all the actions, you need a way to say how to go back. So it's kind of n-square when you want to develop many features. You want to add one, and you have many others so that it integrates well. And what I want to present in this presentation is how to the secret sauce of adding features in 3 simple steps. As you can see, that's what I wanted to say. The structure of the presentation can be visually visible, and so now we are clearly seeing that we have finished one thing and we are going to the next one. So let's go to it. The first one is discipline. So I will tell you my schedule. So I wake up always very early. I do a lot of, because the mind and the body has to be very, it is connected. And for the afternoon, I guess the most important one is this one. The rest, yeah, it's less important. So yeah, if I have an advice, is to get things done, so things are done after. Second one is a test. Unfortunately, it's a bit embarrassing that I don't have a lot of tests, so I will speak about something else, which is splitting the work. And yeah. Okay, I'm going to the jokes are finished. This is not a joke. I'm not programming in Zig. These are the actual content of the presentation. How do I leverage OCaml to have all these features? And the little backstory is that when I started Slipshow, I coded it with my limited knowledge, and it was in JavaScript, and it was very badly written. And then I tried to add some things to it, so it grew a little bit in size. And at some point, I learned OCaml, and I wanted to continue working on it, and I started doing the compiler, because before you would write HTML with some things added in the HTML, and the runtime will run in JavaScript. And after, I added the Markdown compiler, which will take the Markdown and compile it to HTML and do some things to make it better for the runtime. But it was very hard to have both sides communicate, and also it was impossible for me to add a feature to the runtime because I didn't understand it anymore. And so I added a lot of features to the compiler, but then got stuck because... and then I rewrote it to OCaml, and everything was nice. So let's have a small overview. I have a lot of time. Of the thing I use. So I often hear that the ecosystem is not so big. I don't know many other languages, so I don't have a lot of comparison points, but I don't think it's so true for me. So I use a lot of tools to not have to do things. And I rewrite them when I'm happy to do that, but most of the time I don't. So like the help page, I will never in my life have such a nicely presented help page without something that generated for me. I don't know how many languages can compile to JavaScript, but that's crazy for me to have the same thing and all the communication handled and same language for both sides. I use CMarket to parse the markdown. I use perfect freehand to generate the stroke. So when I annotate, like you cannot see it very well here, but it is somehow pressure sensitive based on how fast you go. And this generates stroke. And wait, perfect freehand. So perfect freehand is a library that TLDraw made, and if you know that. So that's a JavaScript library. And with bindings, you can not only have all the OCaml ecosystem, but also all the JavaScript ecosystem. So it's a bit bigger. And many people release or write bindings. It's not very hard to do. And for instance, the collaborative editing use Code Mirror that has binding written by other people. Another example of the ecosystem, like finding libraries that are suited for you in the ecosystem, is I wanted to still have some tests. And the problem, I wanted something that is similar to JQ, but for HTML. Because I generate HTML, and actually the code is inside the argument of an iframe, the src doc argument of an iframe. So it's a bit complicated, and I needed a tool like JQ, but for HTML. And I looked into things like that. They were not working so well for me, and it was difficult to integrate in CI because I need, or to tell OPAM that I had this dependency. And in the end, I had the idea maybe there exists a tool like that in OCaml, and I just Googled it and found that Lambda Soup was perfect just to write a very easy JQ for HTML. So the HTML is not, the ecosystem is not that. The second thing that I'm very satisfied with is the language. I try to use as many features as I can, but I'm still missing a few of them. And today I'd like to show you one thing. So sorry, it's monadic binds. And it's about, so I told you that one thing which is difficult is handling the going back feature. You have many actions that you define, many things that like updating the hash at the top that says at which step you are. There is a lot of logic in going in forward in a step, and I don't want to have to do that all again when going backward. So I want a way to do it automatically. And I will use what I call the undo monad, which is two things. So some alpha with undo is two things. It's a normal value, but it has also an undo function attached. And the idea is that when you generate a value, you might have done some side effects. Usually you generate a unit, but sometimes you need to also propagate a value. So you do some side effects while computing a value, and these side effects are you have a function to undo them. And so, for instance, I'm going here to show you the undo function to set a reference. So I have a reference given as input here, and a new n, so it's an int reference. and I want to set a new value for x. It's easy to know what is the value. It's unit, just setting x to n. But what would be the undo function? Well, how to undo a value that is set? I see your faces that already know the answer. You just remember the old value before the closure, of course, and then when you call the undo function, you put it back. So this is the atomic part of things with side effects that are atomic. You have to define the undo function. But then the important part, I don't have many atomic things. I have like set class, things like that, or set style. The important part is to have a way to combine things with undo. So here I have a value which has had some side effect that you can undo, and a function which takes a value and will generate some side effects that you will be able to undo. And we want to have a value beta with side effects that you can undo. So I'm asking you, what do you think? So the value at the result is y of v, y being the result of f applied to x of v, the value x. But what is the undo function? How to do it? So it's very complicated. You have to first undo the last side effects, and then only undo the first one. So don't do the other way around, otherwise it won't work. And that's all, basically. Now you have atomics, atomic values, atomic ways to modify things, way to combine them, and you can combine them. So, for instance, here I have a reference, x, and I use, just for syntactic reason, the let star, which is just a way of combining the computation of x is 5, and the rest of the body, which is x is 7. X is set to 7. I have a hidden block which just says that let star is bind, and that comma equal is set with undo. And I have also added some logs. So this is actually executed. And you can see that executing this logs that x has been set from 0 to 5 and then from 5 to 7. And if then we call the undo function, we have that x has been set from 7 to 5 and from 5 to 0, so it's back to 0, and we actually have undid the computation. And that is used in a lot of parts in Slipshow, so that I don't have, when I'm defining the forward action of the forward logic of an action, I get generated automatically the undo thing. In the JavaScript, it was done very differently, and it was not working at all. So I'm always almost reluctant to go back, but now it has always been working. And this is just one example of one feature of the language of OCaml that I have found very, very useful to use in the code base. And the last thing I want to speak about is the tooling. So, like, for people used to OCaml, it will be very basic, but for people who don't really know how working with OCaml looks, maybe it can be interesting. So I use a lot of the tooling. So, for instance, the build system, Dune, the build is a bit, like, it's not too simple because I need to generate the engine, the runtime, and then embed it into the compiler. So it's kind of two-step, but I have had no problem using Dune to do this. I also had no problem to vendor things because, for instance, I'm modifying CMarket library to handle the annotations, the actions, and you just have to git clone at the right place and somewhere. and it will pick up easily. And also, I have all those other projects like SlipHub or the VS Code extension and all that. And I can just put them in the parent folder and add a Dyn workspace file. And then when I want to test if my changes in Slipshow has had impact on the other things, I can just run done build from there, and I will have everything told to me. For some reason, I cannot see here. The other thing is Merlin and OCaml iglot, so the fact that there is many features, each time I add a feature, I have to refactor a lot of the previous feature to accommodate the new one. And so I need help because I cannot really do it without help. And I'm showing how OCaml helps me. So here I have a type for events because there is communication between the speaker notes and the main window. And when I draw in one, the other has to draw also. And so they communicate using events. And here I want to add an event. I want to add that I can have a square. I can draw a square, for instance. And I just give it's a fixed width square. I give its coordinates. So what happens when I add this? I can just run dyn build. And it will tell me all the places in the code where I'm not handling this new event. And so here I can go to it, and I will see that I'm not handling it. So I should handle it. But I don't remember which new event it was. How was it called? I can just call destruct on it, and it will automatically find the thing that is not being handled and complete it for me. And I don't remember what is what contains a square, and I can also just do some Merlin destruct, which helps a lot in being guided when you refactor. This is the first example, and let me go back to here and remove this as well. Another use, the really cool use of the OCaml tooling. So I think I need to do this for some reason. And I can do, I need to compile it again because I reverted the thing. And then I can do OCaml iglot occurrences, and I get all the occurrences of the ready message. So I don't know what ready is, and I can see where it is used in all the files. So I know it is used in the previewer, which is a thing that handles the hot reloading. And I know it is sent by the messaging module. And I know that it is also used in the scheduler, which is the one that schedules the speaker notes. So when you open the speaker note, it has to load another instance of Slipshow and get when it's ready to show it or things like that. So I can very easily find what is doing something by just looking at where it is used. And yeah, so that's the 3 steps. Of course, the language itself is helping me a lot in the refactoring. I only spoke mostly about this for the tooling part. And I'm finished. I think there is, the left is, I have a lot of feature, and the right is I use OCaml and all the tools it has to offer to cope with that.
Yeah, the best demo so far. I don't know. Okay, I see the questions.
Wow. I have a question related to the undo monad. Even I think that I understand the code. How does it materialize into your slideshow?
Okay, so it's, let me go back to it. I'm using a very great library, OCaml. So as you can see, I can change it. And I even have Merlin helping me. It is a tool that Arthur Wenling did for blog post, I think, mainly, and it is great. You can also like include some libraries, and it's working very well.
It was not really my question, but I'm really glad to discover this new tool. It was so we can define a way to going further and going back.
Yes.
But I imagine that, and maybe I missed something. I have to define. For example, let's imagine that I draw something. It's my responsibility as a speaker to write the undo function.
So if you do your custom actions.
Yes.
Yes. So if you do your custom actions in JavaScript, then you have to call that. That's why I have to go back.
Okay, but there is a JavaScript API to deal with undo action for custom blocks.
Yes. So
okay, perfect.
You have several. Yeah. What did I want? Where did I want it to go? I don't remember. But you have you call slip.setClass,
okay,
and then this will put something into a reference. So you can, but you can also at the end say, here is my undo function. So you have, like, either you do it transparently by calling the slip function, or you return something that has a specific form and includes an undo function.
Perfect. Thank you very much. An awesome tool.
Thank you.
So you spoke at length about the how exactly you combine undo functions and create undo functions. It seems like there's a fair amount required from the developers to maintain those undo functions and ensure that they are correct, at least for the primitive operations. It seems to me like if you had chosen an immutable representation, you might not need to do something like that if you stored immutable structures at certain checkpoints. So I assume there was some compelling reason that you used mutability. What was that?
So the main reason is that I want to allow people to use third-party libraries for drawing animations. So as I said, so for instance, when I look at random math educational videos, I'm always amazed at how it's good. And it's often because the visualization helps a lot to understand the concept that otherwise is very hard to understand. And sometimes in a only text-based thing, like in academia, there is a wall of text and you don't understand. So I wanted to do something where you can have animations, and I don't like. It needs to be. Not everyone wants to learn a new animation, so there are a lot that are already available, and I wanted a way so that it's very easy to define a new action. And I mean, where you can escape. And if there is a specific state that I maintain and no one can do something else outside of this, I think it's not easy to escape.
Good. Any more questions? Yeah.
No NeoVim, by the way?
Yes.
I feel personally attacked. Okay. You also wanted to ask about NeoVim? Okay.
Damn, Dimitri.
Okay.
NeoVim everywhere.
Okay.
Is this NeoVim Conf?
I wish. Okay. So, yeah, okay. So, yeah, please, one more round of applause for Paul-Elliot for this amazing work.